again, I'm sorry because Chow stole my physics book. I'll have to ask you to read it to me. So maybe I should write down all the information first. So we have Mars, right? But you know what, Matt, why don't you read it to me and I'll write the information down. Just pause when you give me a number so I can write it down.
From an observatory on Earth, Mars is observed as having two moons.
Mm-hmm.
One of the moons, called Phobos,
Mm-hmm.
is observed as orbiting Mars at distance of 9,380 kilometers from its center.
So that's like here to here. Okay.
And the orbit takes 7.65 hours to complete.
Okay.
Finally, the radius of Mars is estimated as 3,390 kilometers.
3,390? Is that right?
Yes.
Okay.
NASA is planning on sending a small 100 kg probe to Mars.
Okay, I'll draw it here. Here's NASA's probe.
Helps NASA out by answering the following. You may assume a circular orbit when necessary. One day on Mars is 24 hours and 40 minutes.
24 hours and 40 minutes. Okay.
Estimate the mass of Mars.
Is this like part A?
Yes.
So I think what we have to use here is Kepler's third law, right? That says T squared is 4 pi squared over gm, is that right? Gm or cubed? Yeah? So then that means m is 4 pi squared or cubed over gt squared. So that means m is 4 times pi squared times 9380000 cubed over 6.67 times 10 to the minus 11 times bracket 7.65 times 3600 squared. Now, are you bashing that in, Siba? Yeah? Let's check what Google has to say too. Did you get that, Matt? 6.44 times 10 to the 23. Now that's not bad because I just checked here on Google. The real answer is 6.39 times 10 to the 23. Yeah, so not bad for two physics students, 9 o'clock class on a Tuesday morning, right? Okay, B, what's the next question? Maybe you can give it to me, Siba. What do they ask next?
How fast is the total moving around Mars?
So that's V equals omega r, which equals 2 pi r over t, right? So that's 2 pi 9380000 over 7.65 times 3600. Okay. You said 2141. 2140. Again? Oh, sorry, meter per second. I wrote kilometer, didn't I? Again, that's not bad because when I look it up online, Phobos is travelling at 2138 meters per second. Not bad, not bad. Okay, Matt, what's C?
Phobos radius can vary up to 10%. Approximately what is the fastest and slowest speeds it will achieve when orbiting us?
So you have the formula V1 or 1. What's the or? 9380000. That's equal to V2. Now let's do the bigger one first, where it's 10% bigger. So that's 93800. I lost my number of O's. Plus 10%, which is 93800. So, anyways, you can get V2 will equal 2140 times 0.9. So, what's 2140 times 0.9? Huh? Should be bigger. Oh, sorry. Should be smaller. Thank you. What is it? 1926 meters per second. And then you repeat the process for the other one. It'll end up being 2140 times 1.1. So what do we get here? 2354 meters per second. So there's the two different speeds for Phobos. Okay. Right. D.
What is the density of Mars?
Right. Density is mass over volume. Didn't we work the mass out earlier? It was 6.44 times 10 to the 23, and the volume is 4 over 3 pi, and the radius is 3390 kilometers. Okay. It's about 400, is it? 3946 kilometers per meter cubed. The true answer, 3930. Okay. What is next, Matt?
What is the gravitational field strength on the surface of Mars?
Right, so that's just this. So that's 6.67 times 10 to the minus 11 times 6.44 times 10 to the 23 over 3390000 squared.
3.74.
What is it?
3.74.
Pretty small. Okay, Sita, what's F now?
What is the altitude of the parking orbit when the hover on Mars?
So, parking orbit means that the time is 24 hours and 40 minutes. So that's 0.67 hours. Yeah? That was right, you have to be careful. What formula will we use here? We could use Kepler again. T squared equals 4 pi squared over gm or cubed. Come on in, so who are you looking for?
You.
Me?
Yes.
Privately or in front of these guys?
Probably privately first.
Okay. You can try and get the ore out from this, okay?
It's a small group you have today.
It is a small group,
Yes.
isn't it?
Yes.
I think we have sleepyheads not here right now.
Remember not yesterday, Stephen asked us to come early.
Did he?
Yesterday,
Oh, no. Yeah.
and no one came.
No problem. Right. Did you manage to get the radius out there? Did you get a radius? So you have or equals cube root GMT squared over 4 pi squared.
Didn't you have to minus the
Yeah. I know. So I was just asking for the radius first. What did you get for the radius? Or did you already minus the... 20475 and then we have to minus 3390. That gives us the altitude. What is it?
170,85881.
Like this? 1708588? 1. So that's 17100 kilometers? Wait, that's not right, is it? That makes it a kilometer. 1, 2, 3, 17,000. Yeah, okay. 17,100 kilometers. Yeah. Okay, what's next, Siba? Right, so that's just using GM over R squared, which is 6.67 times 10 to the minus 11 times 6.44 times 10 to the 23 over 20475,881 squared. That's small, is it? Wow, 0.1024. Okay. Right, what's next?
What is the total kinetic energy and potential energy of the flow qualities in a parking model?
Oh, why am I being such a jerk? Is this the last question? Thank goodness. Right. So the kinetic energy is a half mv squared, and the potential energy is gm m over r. Yeah? So that's a half mass of the probe. The v, remember, is omega r, which is 2 pi over t r. So that's 2 pi r over t minus g, mass of Mars, mass of the probe, over 20475,881, like that. Let's fill in more numbers. So that's a 50. No, and then multiply by, that's 100. So that's 314. The time it's a parking orbit, so that's 24.67 times 3600. The radius is 20475,881 minus 6.67 times 10 to the minus 11, but that's 10 to the minus 10, 10 to the minus 9, over 20475,881, and the mass of Mars, what did we get for that? 6.44 times 10 to the 23. Kaboom. Right. Bash that in, we should get an answer. Yeah. Oh, you're making me sad, Matt. Is it? Is it? Oh, you're right, Matt. You're right. Now I'm so sad. Okay. Sorry, guys. So, look, you can fix it. Put a square here. Put a square here. Put a square here. And then we need another pi and a 2. Sorry. What a disaster. 2 pi times 314 times 20475881 squared over 24.67 squared times 3600 squared. I think I only made one screw up, fortunately. You got an answer, Siba? Minus, because it's trapped, okay? 1049. 123. 123. Minus 105 megajoules. Thanks.
I just realised how little emergency stamping we have to do around campus. That's why it's good to have a Harry's
A good stamp.
a good stop down to Cav. I'm just thinking about the other students.
Oh, we can send them a message if they wake up, huh?
Would you be
We
able
have to
send a
move
message?
room now.
Yeah, that's great. So I don't need to email.
No,
You have all the
don't.
numbers, yeah?
Don't. We have them in WhatsApp, don't
Yeah.
we? Yeah.
She didn't look in the email anyway.
No. I say they're resting well now. I think
Okay,
is
so
what's
we're
happening.
not exactly concerned at this point in time
No.
that a student will come in going, Stephen!
Can you see those guys doing that? I can't see them doing that, so I think we're all
I mean,
right.
it's supposed to be 6, isn't it?
Supposed to be 6.
Right.
No, it's supposed to be 5 now.
Of course, yes,
Yeah.
yes, 5, okay.
Yeah.
Still not great percentage-wise.
It's still not great percentage-wise.
No.
No.
I can do that with my hands too.
No need for fingers for that one. Alright, did you write that down? Okay, so yeah, as you heard, we'll have to move now to a different room, unfortunately. So we have to go to B301. Do you want to send a message to those guys just in case they show up? Just in case they show up. I think we all know they won't, but just in case. B301 is what you said, yeah?